In this video, I'll be addressing the concept of a mole. So this is going to be a little bit different from the furry little rodent or the blemish on your skin, but something that we'll be using in a chemistry context. So the mole is essentially the name for a number, and so I'll write this up for us that 1 mole is equal to 6.02 times 10 to the 23rd. So this is a pretty large number, but the way that we use it is very similar to another number that we have a name for, the dozen. So if we think about a dozen as being equal to 12, in the same way, this mole that we're talking about here, is equal to 6.02 times 10 to the 23rd. One thing that is important about this is that, like the dozen, the mole does not refer to any specific type of measurement. So for instance, we could talk about dozens of bagels, we could talk about dozens of eggs, we could talk about dozens of donuts, and each time it just means that same number, 12. In the same way, 1 mole can represent 6.02 times 10 to the 23rd atoms, or it could represent that many molecules, or it could represent that many stars. It really doesn't matter. So to put it down in the clearest way that I would say that the 6.02 times 10 to the 23rd, the unit for that I would give is just that it is individual pieces. Okay, so 1 mole represents 6.02 times 10 to the 23rd individual pieces in the same way that 1 dozen represents 12 individual pieces. So how did we come up with this number? It seems like a pretty random one just to pick out. The way that the mole was defined was 12 grams of a specific isotope of carbon. So this is 12 grams of carbon 12, the 12 referring to its mass number. So this is a carbon atom that has 6 protons and 6 neutrons. 12 grams of this was essentially massed out, and through experiment it was found that it has this many individual atoms. So 12 grams of carbon 12 has 6.02 times 10 to the 23rd individual atoms. So in this case, our individual pieces are atoms. So this is going to be important for us working forward because the idea behind having a mole is that atoms are very, very small to work with. And if we were dealing with individual atoms and measuring them out as such, we would end up with very large numbers, even if we have relatively small measured samples. So we came up with this mole as a way to get some more reasonable numbers to work with as we're doing our calculations. So because of this, we will need to be able to relate back and forth between this many moles is this many atoms, or vice versa if we want to convert atoms to moles. So now that we've had the introduction to what a mole is, we'll come back to this and practice some conversions in the next video.